technology we're talking about today is a new 3D printing technology. It's what we call fused filament fabrication. That's the desktop printers, the sort of hobbyist printer that you're used to seeing in schools and in people's homes. But the problem has been that the parts that they produce tend to be too weak mechanically. They're just not sufficiently robust to hold up to what a soldier is going to subject those parts to. So we've been doing research now for a few years trying to develop new feedstocks that can be fed into those printers, and using those off-the-shelf, low-cost printers produce parts that are mechanically strong and stiff. What we've done is we've combined two different polymers together into a single filament, and each of those polymers has unique characteristics that are useful for printing and building strength. What we do is we first create on a 3D printer this solid body here, which is called a preform. If you look at this preform, you see there's a white part and a red part. The white part is a higher temperature polymer called polycarbonate. The red part is a lower temperature polymer called ABS. Then we actually convert this back into filament. We use a thing here called a thermal draw tower that we built, and it starts producing filament that looks like this from that draw cone. That gets fed down through some diameter sensors, some tension sensors, there's a take-up reel, and at the bottom, once you get this process going, you can make a large spool of filament like this. This now becomes our new filament for 3D printing. I can feed this into any conventional desktop printer. After printing, I put this in the oven at an elevated temperature to get those layers to really fuse together. I believe we're going to be able to cross a threshold now that we can have low cost, easy to operate, easy to maintain printers proliferated on the battlefield.